Hello dear students, this is Srimati Ashwini, Assistant Professor of Mathematics. Let's see the problems on finding extreme values. In the previous sessions, we have discussed about the minimum value and the maximum value. In this particular problems, we can either get minimum or maximum value. Let's go to the problems. The first problem says, find the extreme values of the function f of x comma y is equal to x cube plus 3xy square minus 15x square minus 15y square plus 72x. So let's solve the problem. We call this as equation 1. Now let's differentiate equation 1 partially with respect to x and y. Since most of you all are comfortable with partial derivatives, let's directly solve them. So fx becomes 3x square plus 3y square minus 30x plus 72. This we have got by treating our y to be a constant. Now let's find out fy. So when I am differentiating fy, you know x would be treated as a constant since it is partial derivatives. So fy becomes 6xy minus 30y. Let me finish off fxx. Ffxx would be 6x minus 30. Fyy would be again 6x minus 30. Fxy would be partial differential of y with respect to x, that would give me 6y, which is here. To find the extreme values, the condition is fx is equal to 0 and fy is equal to 0. When I take fx is equal to 0, I would be getting an equation which is x square plus y square minus 10x plus 24 is equal to 0. This is by taking 3 common. When I take fy is equal to 0, on simplification, I would get y is equal to 0 and x is equal to 5. Now, we will be putting y is equal to 0 in equation 1 to get x values. Later on, we will be putting x is equal to 5 in the same equation to get y values. So the first one is, we put y is equal to 0 in equation 1. The equation reduces to a quadratic equation of the form x square minus 10x plus 24 is equal to 0. This on simplification gives me x is equal to 4 and x is equal to 6. So the points are 4, 0 and 6, 0. Now let's put x is equal to 5 in equation 1. So I get y square minus 1 is equal to 0, y square is equal to 1 or y is equal to 1, minus 1. So when x is equal to 5, the values of y are 1, minus 1. Therefore, the 4 extreme points are 4, 0, 6, 0, 5, 1, 5, minus 1. Now, we need to check each point whether it's going to be maximum or minimum or saddle point. At 4, 0, the value of r would be minus 6, s would be 0 and t would be minus 6. Now when I substitute this in rt minus s square, my answer becomes 36. This is greater than 0 and r is less than 0. Therefore, f of x comma y is maximum at 4, 0. Let's put this value in the given equation. Hence, f maximum becomes 112. At 6, 0, the value of r is 6, the value of s is 0 and t becomes 6. When I substitute these values in rt minus s square, I get 36. This is again greater than 0 and the value of r is 6. This is also greater than 0. So if both the conditions are greater than 0, we all already seen that f of x comma y would be minimum at that particular point. So f minimum at 6, 0 gives me 108. The third problem is 5, 1. The value of r is 0, s is 6, t is 0. So rt minus s square becomes minus 36, which is less than 0. If rt minus s square is less than 0, you know that particular point becomes a saddle point. Therefore, 5, 1 is a saddle point. The next and the last point would be 5, minus 1. The value of r is 0, s is minus 6, t is 0. So when I substitute in rt minus s square, I get minus 36. This is also less than 0. Therefore, 5, 1 is a saddle point. So out of 4 different extreme points which we have got 2 points to be saddle point, 1 point to be maximum, the other one to be minimum. Hence, maximum value of f of x comma y at 4 comma 0 is 12 and minimum value is 108. Let's see the second problem, which involves a trigonometric function. So f of x comma y is equal to 1 plus sine of x square plus y square. Let me differentiate this partially with respect to x and y. So fx becomes cos of x square plus y square into differential of x square plus y square with respect to x gives me 2x. Same way, fy becomes cos of x square plus y square into 2y, which becomes 2y into cos of x square plus y square. Now, without going to the next slide, let me finish off what is fxx, fxy, fyy. I want you all to solve it simultaneously as and when I keep telling you, so that it becomes for you all very easy. Now, f double x, when I say f double x, you know it involves two functions here, right? 2x is a function, cos of x square plus y square is a function. So, we would be using u into v rule. So 2x as it is, differential of cos is minus sine of x square plus y square into 2x plus cos of x square plus y square as it is into differential of 2x is 2. You can look it, that is what we have got. So on simplification, I get minus 4x square sine of x square plus y square plus 2 times cos of x square plus y square. Let me go back. Now let me find out what is fxy. That is, I have to differentiate fy partially with respect to x. So 2y becomes a constant. Differential of cos would be minus sine of x square plus y square into 2x. So that gives me, you can see here, it is minus 4xy into sine of x square plus y square. Now let's finish off fyy. So again it's a product rule. So 2y as it is, minus sine of x square plus y square into 2y plus cos of x square plus y square remains the same into differential of 2y is 2. So this is what you get, which is minus 4y square sine of x square plus y square plus 2 times cos of x square plus y square. For extreme values, we have been doing this everywhere. The condition is fx is equal to 0 and fy is equal to 0. When I take fx is equal to 0, I get x is equal to 0. When I take fy is equal to 0, I get fy is equal to 0. So the extreme point is 0, 0. So at this particular point, we need to find the value of r, s and t. So the value of r at 0, 0 gives me 2, because you know sine 0 is 0, cos 0 is 1. So 0 plus 2 into 1 gives me 2. The value of s is 0 and the value of t is 2. So when I substitute it in rt minus s square, I would be getting it as 4, which is greater than 0, and the value of r is also greater than 0. Therefore, f of x comma y is minimum at 0, 0. So when I put this particular value in the given equation, I get 1 plus sine 0. Sine 0 is 0, so 1 plus 0 is 1. So in this session, we have studied the extreme values wherein the function can either be maximum or minimum or even saddle point. Thank you, my dear students.